Hi class, this is Mr. Kim, and sorry I'm not in the class today. I am still recovering from the ankle injury. Um, I hope that I'll feel better tomorrow so I can see you guys again. We are going to learn inverse trig, sine inverse, cosine inverse, and tan inverse. So we are still going to build off from what we have talked about before, SOHCAHTOA, and we're going to be using these trig functions to help us solve the triangle, any right triangles basically. And we'll discuss what that means um, in the near couple times in the next couple slides. So first, let's do a little bit of a review. So this is going to be sort of like you do now, but at this point, I would like you guys to pause the video, and I would like you guys to start figuring out the 6 trigonometric functions of the angle theta. So what I mean by that is sine of theta, cosine of theta, and tangent of theta for all of these 3 triangles. And notice how they are missing this length um, here and here and here, and you will have to solve for those sides by using Pythagorean theorem. Yes. So pause the video now, fill in this table right here, okay, and then once you're done, then just start the video again. So now I'm assuming that you're finished. Let's go over this. Here, for this first triangle number 1, I'm going to write number 1, number 2, number 3 like this. Sine of theta would simply be opposite over a hypotenuse, right? So we know that it's so, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So in order for me to do sine, I would have to take the opposite side to the angle, which would be, this is the angle, and then opposite side for that would be 8. Now the problem is I don't know what my hypotenuse is, but you have to figure that out by using the Pythagorean theorem. So here, if you use a Pythagorean theorem, it will be 8 squared plus 15 squared is equal to c squared. And type that in your calculator, you would get 64 plus, so it's 64 plus 225, which would give you 289, which gives you c squared. And then that means that c would be 17. So your hypotenuse would be 17. So you can just kind of write it over like this and then have the hypotenuse written out. So you'll have SOHCAHTOA, sine would be 8 over 17, cosine would be 15 over 17, and tangent would be 8 over 15. Now for the next one, you will have to do Pythagorean theorem again, but this time your hypotenuse is given. So 25 is equal to a squared plus b squared. So it will be 25 equals to 4 plus b squared, because you know how 2 squared is 4. And 25 minus 4, and you square root it. So this actually becomes square root of 21, which is close to being around 4.5-ish. 4.58. So what you can do is you can take, hey, this is the angle. You can just write simply opposite over hypotenuse, which is 2 over 5. Cosine would be root 21 over 5 or 4.58 over 5. And then you can do tangent of theta, which would be 2 over root 21 or 2 over 4.58. Now some of you guys might notice and go, oh, this is square root in the denominator, so I can rationalize it. So 2 over square root of 21 times square root of 21 over square root of 21 gives you 2 root 21 over 21. You could do it like that. The last one here, I'm going to erase this. You still first have to figure out what your last side is going to be. Now notice you're already given a hypotenuse here, so once again you're going to do 3 squared equals a squared if I were to call this side a, and I would then make b to be 1, right? So then that will be 9 is equal to a squared plus 1. So a squared would be 8. So square root of 8 would give you what the value of a is. So this would be square root of 8, the last side. Same, about close to be 2.82 if you were to type that in your calculator. So sine of theta here would be opposite, which is root 8 over 3. Your cosine of theta would be 1 over 3, and your tangent of theta would be root 8 over 1, which is the same thing as saying root 8 here. Because your angle is up here, which means your opposite side would be the root 8. You have to watch out for that, so I'm going to use a different color. This is your angle right here, root 8. I mean the theta. So that means your opposite side would be the root 8. And your adjacent side would be 1, and your hypotenuse would be 3. So these will be the answers for the review part. And let's go to the next one. This one, I don't know why the picture's a little off to the side, but in this case, this is really nothing new. You will have to find out what x is, but what I'm testing you to see is the angles that you see before is all 30, 45, or 60 degrees. You know this from special right triangles. So you should know that here, y should be the same thing as saying 7, because they're going to be the same, because this will also be 45 degrees. That means x would be 7 root 2, because you have to take this side and multiply by root 2 to get x, so these two will be the answers for that one. The next one here, we have another 30, 60, 90 degree triangle. The hypotenuse is given as 10, so x, the opposite side to 30 degrees, will be the smallest side, half it, which is 5, and y should be 5 root 3. And 6, you have 60 degree side, and across from that is 3, which means to find the 30 degree side, see, opposite from 30 degree side to 60 degree side, you multiply by root 3. So if you want to go the opposite way, you would have to divide by root 3. So which makes this one, y to be 3 divided by root 3. Rationalizing it would give you 3 root 3 over 3. Cancel it out, and you have just square root of 3. So y is square root of 3, and x is going to be 2 times that, because once you have your smallest side, you can just double it, so it will be 2 times root 3. These are just a review of 30, 60, 90, or 45, 45, 90 degree triangle. Nothing in particular new, but you still should be able to do this on your own. So once you're done with these review problems, you should just go to this video and just check your answers. If you can, just try these on your own, and then try to look back as to how you did it and compare my answers to that. Okay, so let's do another review here. This is going to be solving for x. The most important thing, as I mentioned to you guys before, is always, always, always to set up your trig ratio. How you set up your trig ratio is very, very important. Note, first scan for what you're given here. You have your angle at 25, you're given your opposite side, and you're given your adjacent side in respect to this angle 25 degrees. So here you're going to be using tangent, because the tangent uses opposite and adjacent, which means tangent of 25 degrees would give me x over 18. And then all you have to do is multiply by 18 on both sides like this. So go to your calculator and make sure your mode is in degrees. You guys know how to get there, yes? Mode is right next to second. Press mode. The third line has radians or degrees, the option. Please choose degrees. So when you do 18 times tangent of 25, you should get x is equal to 8.3935 or so. Next one, 3b, you have an angle here. In respect to this angle, 15 should be adjacent, x should be hypotenuse. The trig function that uses adjacent and hypotenuse is cosine, so cosine of 70 is equal to 15 over x. Now notice how x is in the denominator, so that means you have to multiply both sides by x first to get rid of the denominator. So then it will be x times cosine of 70 is equal to 15, because x is now gotten rid of. Then divide away cosine of 70 degrees on both sides, and you will get x by itself. So x is 15 divided by cosine of 70 degrees, which gives you 43.85706. Okay, so make sure you are comfortable with doing 30, 60, 90 at this point, 45, 45, 90, finding the ratios of the sides. I mean, it was part of your test as well. But also, the new stuff that we learned, which was sine, cosine, tangent, and solving for x using the trig functions. Okay, now we are going to be introduced to something new, the inverse trig functions. You're going to be asked to solve for now, not the ratios of the sides, not the trig function like opposite over adjacent and stuff like that, but you're going to be asked to solve for the angle. So for example, the angle A. How do you solve for this angle? Like, what is the actual amount of degrees? We're going to be using theta for most cases to represent an angle. How do we figure that angle out? Well, it turns out that if you use what we call inverse trig functions, we're able to take the ratios of the side that's given, and then we can use that to find out what the angle is going to be. So, first, we're looking for the angle A. In respect to this angle A, we're given the side 18 and 27. 18 should be your opposite side, as you should know, and 27 is obviously the hypotenuse. So the trig function that uses opposite and hypotenuse will be sine, right? So if I were to set up the trig function, sine of this angle A, I'm going to call it theta because we don't know what this is. Sine of theta would be 18 over 27, or simply reduced down to 2 over 3. Now, in order for me to figure out what this angle is, because this is my goal, what is this, how many degrees would this be? Rather than me just keep on plugging in and checking what the angle is, we're going to find this by taking what we call inverse sine. Remember when we given 2x equals to 4, we divide away the 2. Since 2 and x are being multiplied, we do the opposite, right? So here, it's a sine of the function theta. What we're going to do is we're going to do inverse sine, and we're going to do inverse sine of the other side as well. And what happens is this and this actually cancels each other out. Remember, it's not sine times theta, so we're not dividing away by sine. We're going to take away the function that's inverse. So with the inverse is always notated by this negative first power, and this function actually are able to cancel each other out. So how do I figure out what this is? It turns out that if you press second button on your calculator, okay, everyone take a calculator, and go to second and then press sine, on the blue, I hope you notice that there is this button here that says sine to the negative first power. And so that's exactly what we're going to use. So what we're going to do is you're going to press second, and then you're going to press sine, and it should show up as sine inverse, and it will open up a parentheses for you. And then, because what we're looking for is, if you were to go back to this thing that we just solved out for, theta by itself is equal to sine inverse 2 over 3. So that's what you're going to type in here, 2/3, close parentheses, and press enter. And what you will see is 41.810314.9. You guys all see that? That means that the theta, the actual amount of degrees that this would be, is 41.81 degrees. So this is how you use inverse trig functions. You are given the ratios of the sides. You're going to type those into the calculator with the inverse trig function to figure out what your angle is going to be. Now, obviously, with one example is not enough, so we'll do a couple more practices. Now, use a calculator to find the measure of angle A to the nearest tenth. So here, I have an angle A that I want to look for, so I'm going to notate that with theta. Always notate the specified angle with theta. And then, your second step should be to look at what you're given. You're given 6 and you're given 20. 6 in respect to this angle is opposite. 20 in respect to this angle is adjacent. So what trig function am I going to be using? Tangent of theta. And tangent of theta, turns out, is opposite over adjacent, which makes it 6 over 20, reduce it down to 3 over 10. And how am I going to solve for what this angle is? You're going to be using inverse tangent to cancel it out. So inverse tangent on the left-hand side here, inverse tangent on the right-hand side here, and these two will cancel each other out, which makes this, theta, is equal to tangent inverse 3 over 10. And all you're going to do is go to your calculator, type in inverse tangent 3 over 10, make sure your mode is in degrees still, and you should get 16.699 degrees. So the angle here is 16.699 degrees. And what you do is, if you take tangent of 16.699, try it and then see what you get. Tangent of 16.699 actually gives you 2.999, or actually 0.29999. And if you do actually 3 over 10, the ratio of the side that we had, this is actually close to being 0.3. Notice how these two are pretty much practically very close to each other. So that's how I know that I did it right. You can always take the degrees and plug it back into a regular trig function and see if your ratio matches up. Next. Here we're looking for angle A, which is this one. In respect to this angle, we're given this side and this side. 3 is your adjacent, 15 is your hypotenuse, which means I'm going to be using cosine. Cosine of theta is 3 over 15. Reduce it down to 1 over 5. Then, to get rid of cosine, we're going to be taking inverse cosine on both sides. These two would cancel out. I'm going to just cut this like this. So your theta would equal inverse cosine of 1/5. So I'm going to go to inverse. I'm going to go to the calculator, type in inverse cosine 1 over 5, close parentheses, and your theta should be 78.46 degrees. That's it. Inverse trig functions are used to solve for the angle. And the trig function, the regular ones that we talked about, you take sine of angle, you take cosine of angle, and you find the ratio of the sides. So it kind of goes vice versa in a way. Next, I'm going to go over these, and the homework will actually be on the slides as provided for you in Google Classroom. It's just 10 problems, but here, I don't think we just talked about what it means to solve the right triangle here. I think you will have extra time in this class, so if you can, just please go to these problems and try to do as much as you can. So here, for number 12, I'm going to start for number 12 here. Use a calculator to find the measure of z. So I'm going to go to z and mark it with theta for all of these triangles. So let's talk about number 12 here. In respect to this angle theta, we're given 5 and we're given 9. 5 is your opposite, 9 is your hypotenuse, so I know that I'll be using sine. So sine of theta is equal to 5 over 9, which means I'm going to take inverse sine on both sides. So these two would cancel out, and notice how what you're left with is theta is equal to sine inverse 5 over 9. So go to your calculator, type in inverse sine 5/9, you get 33.74 degrees. Next, 13 will be the same way. You have this angle, 10 is adjacent, and 14 is hypotenuse. So that means I will be using cosine of theta is equal to 10 over 14. Reduce it to 5 over 7. Then I know that I have to use inverse cosine. So take inverse cosine on this side, inverse cosine on that side. And so your final answer would be theta is equal to, type it in your calculator, inverse cosine 5/7, and you will get 44.41 degrees. 14, in respect to this angle, I have opposite and I have hypotenuse. Once again, I'll be using sine. So sine of theta is equal to 15 over 25. So in this case, what I'm going to do is I'm going to reduce it 3/5, and then take, I'm going to use different color again, inverse sine on both sides. These two would cancel out. Whatever you're left with, theta is equal to inverse sine of 3/5. And that means go to your calculator, type it in, get 36.86 degrees. Now, if you haven't gotten any of these answers, I would really suggest you to work with another person to help them guide through, or get someone who understands this and help you guide them through like what this is going to be about. Because on the day that I'm coming back, I want you guys to be kind of getting this, not perfectly, but at a certain point understand when to use these inverse trig functions. So for example, if you have opposite over hypotenuse and you're trying to look for the angle, you should know that we're using inverse sine like we did for the first and the third problem like this. Okay, so I'm going to erase these answers now, just maybe 12, just so that I can do question 15 on the screen here. So this will be the last question before you work on your homework. So question 15, it says to solve the triangle. Now, what it means to solve the triangle is, solve the triangle means find all missing side and angles. Okay, so you're looking for all the missing sides and angles. I am missing these two angles, and I'm also missing this side. So I'm looking for 3 different things. Now, if you actually solve for one of the angles here, it actually is easy for you to solve the last angle because you know that all of these angles here, S, T, and R, they all have to add to give you 180 degrees. So let's say that I'm looking for the angle T. In respect to the angle T, I'm given 6 and I'm given 9. So we're all looking at this triangle problem, yes? 6 would be adjacent in respect to the angle T. 9 would be hypotenuse in respect to the angle T. So then that means I'm using cosine. Cosine of angle T, yes, you can use theta if you'd like, but I just use the capital letters just so that there's no confusion. Cosine of T is equal to 6 over 9. So you know that angle T would be inverse cosine of 6/9 because I can just take inverse cosine on both sides and get these canceled out. And what you notice is that inverse cosine of 6/9 gives you the angle 48.18. Now, that means I know what my angle R is right here. See, this is already angle S right here. I'm going to use a different color. Let's use red. Angle S is already 90 degrees, which means the rest of the angle T and R, they have to combine together to give you 90 degrees because 90 plus 90 is 180 degrees. So what we say is that T and R are actually complementary angles. What does that mean? It means that they add together to give you 90. So what is the angle R going to be? So simply take 90, subtract away 48.18 because that's what T is. So 90 minus 48.18 gives you 41.82. So that is going to be it. That's my last angle R. So I've literally found out all the angles that's missing. I have angle T at 48, and I have angle R at 41. Now the next one we have is the last side, the length RS. Let me clear things up here so it's kind of easier to see. So we're looking for this side length, RS, this one. In order to figure that out, there's only really one way that you can do this, or actually there are several ways that you can do this, but you can use Pythagorean Theorem if you'd like. So you know that 9 squared is equal to 6 squared plus, if you call this a squared, and then you can solve it that way, and then eventually what you'll end up with is square root of 45. See, but then there's another way that you can solve for this. See, you already have an angle T at 48.18 degrees. Now, knowing what you know about trig, we know that tangent of T, the reason why I use tangent is because it uses opposite, and we have an adjacent side that's given. You can use sine of T if you'd like, because they will give you the same answer regardless. So tangent of T would give me a over 6, right? That's an a, by the way. It's not a 9, it's a. Maybe I should just call it an x, just to make it a little easier. So x over 6 should be tangent of T, or in this case, sine will be x over 9, right? Well, we already know what angle T is, so let's just substitute it in. So we're focused on here. Angle T is given to us as 48.18, or actually we solved for it, right? And notice how these questions are very similar to the one we did before when we were solving for the x, like these review questions we did. We set up the trig and we get x by itself by doing simple algebra. So here it's the same situation. If I want to get x by itself, I would have to multiply by 6 on both sides. So 6 times tangent of 48.18 gives you around 6.705. Or if you do sine of 48.18 times 9 in this case, because we have to multiply that by 9, right? It gives you the same thing, 6.707, relatively close enough, but they, not exactly the same, right? Because we have a rounding error in our answers, but as long as they look about the same, 6.7, this is not a good color, 6.705 here and 6.707, they're pretty much practically the same. Now what about the Pythagorean theorem that we used, that we got root 45, right? So if you just square root of 45 into the calculator, what do you get? You get 6.708. Notice how all of these three answers, they're pretty much the same. So I'm just going to say my answer is 6.7 and be done with it. Now, do you have to do all three methods? No. You can just use Pythagorean theorem if you'd like, or if you want to be daring and challenge yourself and using the trig functions, which I do recommend, because we're going to be practicing with trig a lot, you will probably want to be using this way. Find out the angle, set up the trig ratio to solve for x, instead of doing it boringly by using Pythagorean theorem over and over again. Okay, so the answer for the side length RS would be 6.7, angle T would be 48.18, and angle R would be 41.82. So solving the right triangle, that question appears again in the homework question here. So there are 4 problems that you have to solve for each triangle. So you have to find the missing side HF, find this angle, and find this angle, for example, for 42. And for the other homework question, you're looking for the angle T. So remember, to find the angle T, you label it as theta. And since you're given opposite and adjacent, you're going to set up your trig ratio as tangent of theta is equal to 8 over 12, and then use inverse trig to get theta by itself. Okay, I know that I'm sorry that I can't be here today, but I hope this video helps you to guide you through what inverse trig function is going to be about. Remember, I'm going to be collecting it on Thursday. If you have any questions, please just let me know, and I'll try to help you out as much as I can. Okay, and thank you, and have a good day.